Okay, 2020 paper 1, question 1a, part 3. Find the two values of p for which the graph of f of x will not cross the x-axis. Now, not cross the x-axis means that the diagram would look something like this. If you had your x and y axis, it would be like floating up here somewhere. Now, that means it has no real roots. Now, that phrase should sound familiar. It sounds so familiar to the point that you remember b squared minus 4ac is less than 0. So the discriminant is less than 0 if there are no real roots. Now, we'll just rewrite the what would you call it? The function again. So it's x squared plus 5x plus p. So x squared plus 5x plus p. So my b is 5, so that's 5 squared minus 4a. Well, a is 1, the coefficient of x squared, and c is p. So that gives me 25 minus 4p is less than 0. Now, to minimize any hassle about signs, I normally rearrange to make the variable positive. Now, it's going to be 25 divided by 4. So that goes in what? That goes in 6 1/4 times. Now, p has to be bigger than 6 1/4. We were also told at the beginning, if we go back to the beginning, that p has to be a whole number, either positive or negative. And we're also told that p is somewhere in between -3 and 8. So if it's bigger than 6 1/4, it can't be 6 1/4 itself because it has to be a whole number. So if it's bigger than 6 1/4, one option is that it's 7. And the other option is that it's 8, because we're told that p, you're allowed to have p up and including, up as far as and including 8. So the two values of p for which the graph does not cross the x-axis is either 7 or 8. Find the range, part 4, find the range of values of x for which the absolute value of 2x plus 5 minus 1 is less than or equal to 0. And x is an element of R. So again, when we have these absolute values, the first thing I'm going to pay attention to here, and you would have remembered from class, is that if there is a constant there, what I'm going to do is I'm going to pop it over the other side. The method that we normally use is we square both sides, and we do that because then we do away with any issues around whether it's positive or negative. Because when we have absolute value, we don't know if that x is originally positive or negative. So that's why we square both sides. To do that, I need to write it out twice. So I have 2x plus 5, 2x plus 5, and my 1 squared is 1. Now I'm just going to multiply this out. So 4x squared plus 10x plus 10x plus 25, and I'll bring the 1 over minus 1. Okay, so that's 4x squared plus 20x plus 24. Now, it might be helpful here to divide the whole thing by 4. It just means we're not looking at numbers that are too big. It just helps, basically. And of course, if it's positive, we can divide by any number as long as it's positive and it doesn't affect the direction of the inequality symbol. Now, at this point, it's always good to imagine our graph. So because this is a positive x squared, it's what I would call a smiley face. Now, wherever the roots are here, we're reading this as the graph is less than or equal to 0. So in other words, the graph is below the x-axis. It is below the x-axis. So whatever answers I get here, it's going to be between them. Now, when we were doing this in class, when we were talking about between, we said that we include this symbol, which means x is bigger than or smaller than, and it's and equal to, because in the question it's and equal to. So that's, we can always replace the word between with those symbols. So now all I have to do is finish solving. So I'm going to do, again, you could do your minus b formula here or your factorizing in your null factor theorem. Because it's an easy one, I'm going to go with my my factorizing and null factor theorem. So the plus here means the two signs are going to be the same. They're both plus because that's plus. So then I end up with 3 and 2. And if I do my check, I get 3x and 2x, which is indeed 5x. Now, each of these are the factors. So if I'm actually solving, I find out that x is minus 3 and x is minus 2. So minus 3 is there, minus 2 is there. But remember, our final answer is we need to explain that it's between those. So my final answer is that x has to be bigger than or equal to minus 3, less than or equal to minus 2. Just double check again at the beginning, are we allowed to have that? Well, we're allowed to have anything that's bigger than minus 3 or less than or including 8. So bigger than or equal to minus 3. So are we bigger than or equal to minus 3? Yes. So we can include the and equal to, and obviously minus 2 is in the mix because you're allowed to go up as far as and including 8. So that's our final answer, and it's job done.